Welcome to Two Projects. In this video, we are going to explain about the project that is BertSent, transformer-based model for sentiment analysis of Penta class tweet classification. So before getting into the execution, first let us understand what is this project about. Sentiment analysis or essay. It is basically a way to understand people's opinions, feelings, or emotions from the text. With the huge popularity of social media platforms like Twitter, Facebook, Instagram, and YouTube, there is a lot of information available about what people think or feel about products, services, or even events. Businesses and organizations use this kind of analysis to monitor their reputation, understand customer preferences, and make informed decisions. However, analyzing social media content isn't easy. Posts and tweets are usually very short, sometimes messy, and people often use slang, abbreviations, or incorrect grammar. This makes it hard for traditional methods to accurately understand the sentiment. Most older approaches like bag of words, engrams, or TF-IDF look at individual words or simple patterns, but they miss deeper meaning of the context of the text. These methods are often limited to classifying text into just positive, negative, or neutral. So they can't capture more detailed emotions or subtle differences in the opinion. There are still quite several few challenges when it comes to sentiment analysis. One major issue is that sometimes there isn't enough data available to train models properly. Another common problem is class imbalance, which means that some sentiment categories like extremely negative or extremely positive might have very few examples compared to others, making it hard for the model to learn well. So here, the multi-class sentiment prediction, especially pentaclass classification, which divides sentiment into five categories, is even more difficult. This kind of classification gives a more detailed view of how people feel, but it hasn't been studied much yet. Traditional slang or abbreviations, they also fail to capture subtle differences in sentiment, like the difference between positive and extremely positive. Tackling these challenges is really important if we want sentiment analysis to be accurate and reliable, especially for understanding opinions on social media. Moving on, so the system we propose is designed to classify tweets into five sentiment categories, which allows for a more detailed understanding of how people feel. So to do this, the system uses a modern transformer-based model called BERT. Unlike older methods, BERT can look at words in both the directions with a sentence, that is within a sentence. So it understands context much better and can capture subtle differences in sentiment and even in short or messy tweets. And the other important challenge in social media is that some sentiment categories might have fewer examples than others, which make the model biased. To fix this, the system uses resampling techniques, specifically random oversampling and random undersampling, to balance the dataset. This ensures that every sentiment category is well represented during training, helping the model learn more effectively and make more accurate predictions. And here, the system works by first cleaning. So the system, it works first by cleaning and preparing the text in an organized way, then converting the words into meaningful numerical representations that capture their context. It is that is, it uses a fine-tuned transformer model to analyze these representations and classify tweets accurately into five sentiment categories, that is extremely negative, negative, neutral, positive, and extremely positive. So we will be categorizing the text into these categories. So by doing this, the system performs better than traditional machine learning methods because it can understand subtle differences in the language and context. This makes it possible to get a more detailed and reliable picture of public opinion on social media, helping businesses, researchers, or policymakers understand how people truly feel about certain topics. And to further improve the sentiment analysis of this project, several improvements are made to make the model more accurate, interpretable, and user-friendly. So first, system is enhanced by integrating LSTM with GRU, along with the upgraded BERT model, that is enhanced BERT model. So these includes extra dropout layers and they are more accurate. These changes helps the model train more effectively and produce more reliable results. And then to make the model decisions easier to understand, Lime has been implemented in this project. So this technique shows which features or words in the text had the most influence on the predictions, making the analysis more transparent. Third, a user-friendly front-end interface has been incorporated in this project. So this is developed by using Flask, and it includes user authentication mechanism also, which only allows registered users to access the system. Then comes topic modeling. Here, latent directlet allocation has been added to the system to extract meaningful topics from the dataset, giving additional insights alongside the sentiment and results. So these are the things which are incorporated in this project. And to implement this project, we have followed these steps which are mentioned in the flow of work. So let's understand them. First, we have imported all the necessary Python libraries to start handling tasks such as data processing, model building, visualization, and deployment. These libraries include Pandas, NumPy, TensorFlow, and Keras. Then comes data integration. So in this step, the COVID-19 tweet sentiment dataset is loaded into Pandas data frame. This allows the data to be efficiently processed and prepared for analysis and modeling. Then comes data pre-processing. So the text data is cleaned and normalized to improve model performance. This includes converting text data to lowercase, removing HTML tags, URLs, and non-printable characters. Punctuations are handled according to the model requirements. Tokenization breaks the text into individual words, and sentiment labels are encoded numerically for the model training. Then comes embedding. So here at this stage, text is converted into numerical form from the models that can understand. Baseline models uses the Keras tokenizer, while transform-based models leverage BERT embeddings to capture contextual relationships in the text. Then comes data visualization. So the dataset is explored, that is visually, to understand sentiment distribution and the text patterns. Word clouds highlight frequently occurring terms, giving insights into common topics. Then comes data balancing. So here in the step, class imbalance is addressed using random oversampling and random undersampling. This ensures all sentiment classes are sufficiently represented during training, preventing model bias towards majority class. Then comes feature extraction. So in this step, relevant features are extracted from the process text. The dataset is then split into training and testing sets to allow model training and performance evaluation on unseen data. Then comes model development. So here models are evaluated on the test set using, here different models are developed, including baseline models, transformer-based models, and advanced combinations such as LSTM, GRU, and enhanced BERT models. Then comes model evaluation. So here we will be evaluating multiple machine learning models that are accuracy, precision, recall, and FN score. After that, we will be using confusion matrix. So this confusion matrix, it helps to identify misclassifications. Coming to explainable AI. So explainable AI techniques like Lime are integrated to provide insights into which features influence the predictions. Then the best performing model will be saved for the future use. Then comes Flask deployment. So here a web application is built using Flask where users can input text or upload files. The app loads a pre-trained model, pre-processes the input, and predicts the sentiment class, and it also performs topic modeling using LDA to extract key themes from the text and displays the result on the web page, including predicted sentiment and confidence scores. Moving on. So these are the algorithms used in this project. So BERT model is built individually with no sampling technique, with random oversampling, and with random undersampling. So this is the proposed model. And here, these are the other baseline models, and these two are the extension models. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. These are the source code files of this project. So we have used coronavirus tweets. Let's open it. So here we have train set, which is used to train the model. It's loading. Just wait for a while. Until then, let's see with the other files. Get back. Here in this model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap files, which are important for the project's appeal, visual appeal that is. In templates folder, we have all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases folder in which we have test cases in it that will be using in the front end. And here is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this is a database file. And in this, we have developed latent dirichlet allocation model, which is used for topic modeling. So this is all about the code folder. Let's see if the data set is opened or not. So yeah, here the data set is open. So here we have username, here we have screen name, here we have location, tweet, and here we have the original tweet that we have used it for training. And here we have sentiment that we will be predicting in the front end. So this data set is used to train the model. Close it. Get back to the folder. So now for executing, copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file, that is by giving Python space app.py, and click on enter. This command will execute Python script and perform a runtime check for any syntax issues or logical errors, that is syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. File is being compiled. So the application has been hosted. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Chrome, so I will paste it in that. So paste the link here and click on enter. So this is the web page of the project, which is displayed in the web browser, which is developed using Flask framework. So here you can see try BertSent now and click on sign up. So first we need to click on sign up and create an account. After creating, you need to sign in. I have already created account, so I'll directly sign in. Give username and the password. Now click on sign in. We have signed in successfully. So I'm asking for resubmission. So we have signed in successfully and redirected to classification page of the project. So here you can see input text box, right? Wherein we need to give the input message. So let's open the test cases. Open test cases. Open this file. So let's apply filter to this column. Apply filter. So let's apply filter to extremely negative. Click on OK. So copy any text of your choice. Get back to the application. Paste it and now click on Analyze Sentiment. So this given information, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us the prediction. So just wait for a while. So here we got the prediction that it is extremely negative. So the sentiment analysis we got is extremely negative. So the sentiment analysis model has classified the text as extremely negative. So this classification is based on advanced transformer-based natural language processing model. And these are the keywords for this text we have given. That is for the text we have given before. And let's try with the another text. So now select other text. So now let's try with this case, click on OK. Let's try with this one. Get back, paste it, and click on Analyze. And here you can observe it is predicting extremely positive. And these are the keywords for that. Now let's check with one more case. So apply filter to negative. OK. And check with this case. So just wait, it's being opened. Paste it and click on Analyze Sentiment. And here we got the prediction as negative. So the sentiment seems to be negative. And these are the top keywords. Let's try with another one. So let's try with this first one. That is for the neutral sentiment. Get back, apply filter, copy the text and click on Analyze Sentiment. And here you can see neutral classification, that is sentiment analysis is neutral. Let's check with the last case. Get back to this. Apply filter to positive. Click on OK. So now let's check with this one. Get back. Paste it here. Click on Analyze. So here we got the prediction as positive. You can observe positive prediction. We have got it. So in this way, you need to do the prediction. Now let's check with the graphs. Click on graph. So here we have the graphs. The first one is sample outcome graph. Here on x-axis, we have all the classes that we are predicting, and on y-axis, we have count. Now close it. And this is the confusion matrix. So this graph is a confusion matrix. Here on x-axis, we have predicted class, and on y-axis, we have actual values. And this is the accuracy comparison graph. Here on x-axis, we have all the models trained, and on y-axis, we have accuracy score of each model. Close it. Similarly, we have precision score and recall score. Here we have recall score, and here we have FN score. This is the FN score. Now click on log out. So the project successfully demonstrates a system that can accurately analyze the sentiment of tweets into 5 categories, even with the limited and imbalanced data. By combining advanced text processing, transformer-based models, and explainable AI, it not only predicts the sentiment effectively, but also provides insights into important features, making it useful for understanding public opinion and trends on social media. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.